So guys, in this video, I'm going to go over the performance final review. So this first question says, Sarah has a frame she wants to use on a painting. The measurements for the outside of the frame are given. The frame itself will be 2 inches wide on all sides. Using the diagram, show how to calculate the expression for the area that will show the painting. All work must be shown. Okay, so on this problem, the whole side on the left is 4x minus or plus 7. The whole side on the bottom is 6x minus 1. So what we want to do is we want to be able to find the height and the width. So I'll show you guys what I mean. I want to be able to find, let me see if I can find some other colors. This one, okay. So I want to be able to find this. And I want to be able to find this, because if I multiply those two together, that's going to give me the area inside there. And it's asking us to find this area right here. Okay, that's what the question's asking us to find. So what would be the height without? So our current height, and again, I'm going to use the green here. Our current height right here is going to be this minus what? This 2 up here, which would also be that 2 down there, right? So we're going to do 4x plus 7 minus 2 minus 2. Wouldn't that be minus 4? Yes. So that's going to be 4x plus 3, okay? Now we're going to find that, and then we're going to find the width as well, okay? So now notice this is our width right here. And again, we've got 2 over here and 2 over here. So we're going to do the same thing we just did a minute ago. We're going to do our 6x minus 1 minus 2 minus 2, right? So that's going to be 6x minus 5. So that's what we're going to multiply, 6x minus 5. Now, most of y'all like the box method of solving problems like this, so that's what I'm going to use. I'm going to use the box, okay? Because most of y'all are very comfortable with that. So I'm going to create a box over here, and I'm going to do my 4x and my 3 there. Wow. I can't draw a straight line today. 6x and minus 5 here, okay? So we're going to do 4x times 6x, that's going to be 24x squared. 3 times 6x, that's going to be 18x, right? 4 times negative 5, 4x times negative 5, that's going to be negative 20x. And then negative 5 times 3 is going to be minus 15. Now remember, in our diagonal are our like terms right there. So we're going to combine those. So negative 20 plus 18 is going to be negative 2. So our answer is going to be 24x. Oops, I forgot the squared, y'all. The x squared. X times x is x squared. So there we go. 24x squared. And again, this is going to be minus 2x because anytime you have a positive and negative, you subtract them, keep the sign of the bigger number, okay? And then this was going to be minus 15. So that is our answer for that problem. Okay, so this is number 2 down here, and it says a company has 2 irregular shaped areas that it wants to turf for outdoor gathering spaces. Using the diagrams below, what is the difference in the area of the 2 spaces? So we're going to find the area of the one on the left and the area of the one on the right, and then we're going to subtract them from each other. So here we're going to do our 2x. We're going to do our 2x times our what? 2x. See that? 2x times 2x is going to be 4x squared. Over here, again, we're doing our 3 times our x, right? So that's 3x. Then this is going to be x times x, so x squared. Again, x times x, that's x squared. So now, we're going to combine our terms, right? So when we do this, we're going to combine 4x squared plus x squared plus x squared. That's going to give us 6x squared, isn't it? And then all we have left is our 3x, okay? So that's one of our terms. And that's the area of all of the stuff in that shape on the left. Now we're going to do this one over here. Again, we've got 2x times what? 2x. So that's going to be our 4x squared again. We've got our 3. Sorry about that. So we're doing x times 3. That's going to be 3x. Here we've got our x times our x. That's x squared. And here again we've got our 3 times our x. That's 3x. So once again, combining like terms, that's going to be 4x squared and x squared. That's going to be 5x squared. And then we've got our 3x and our 3x. So that's going to be 6x. Now it says find the difference of these two things. That means we're going to subtract. And that means we're going to change that to a minus sign, okay? So I'm going to actually cross through that and make that a minus, okay? So we're subtracting, we're changing the signs of both. So 6x squared minus 5x squared is x squared, and 3x minus 6x is minus 3x. So that's our answer right there. So for number 3 here, it says in triangle ABC, AB is 9, BC is 12, and CA is 15. Triangle ABC is reflected over the line y equals negative x. After the transformation, what is AB prime, BC prime, and CA prime? Okay, so these are not going to change, are they? So this is going to be 9, this is going to be 12, this is going to be 15. And it says, is ABC equal to ABC prime? Yes. Why? Because a reflection is a rigid transformation. Now, if you want to put it in different words, then you can say it doesn't change the size of the image, okay? Now, part B, it says that the same shape is dilated by a scale factor of 2. So what does that mean we're going to do to each of the sides? We're going to multiply every one of them by 2, aren't we? So every one of these sides can be multiplied by 2. So this is now going to be 18 and 24 and 30. So this time it says is ABC equal to ABC prime? The answer is no, triangle ABC. Why or why not? Because it's a dilation. And what does the dilation do? It changes the shape, okay? Because it's a dilation, which changes the size of the shape. Okay? There we go. Or in this case, it's a triangle, right? Number 4 says, triangle ABC is transformed to become XYZ. What composition of transformations transforms ABC to XYZ? So in this problem, hopefully you can see. So it says we would do A to X. Y'all see that? So A to X. So A is here and X is there, right? And then we've got B and what? B and Y. B and Y is right there. And D and Z are right there, okay? So I noticed that they do cross. Doesn't look like a rotation to me, though, okay? So this is a composition. So this makes it a little bit different. Our rules that we used in the past don't totally apply here because it's more than one thing, okay? So let's look at this. Can you guys tell that this is A and that would be our A? Yes? Can you tell that this side, this long side right here, AB, is that long side right there? So hopefully all of y'all can see that obviously this looks to me like a reflection over the what? The x-axis, right? That's the x-axis. So if I do a reflection over the x-axis, where's it going to take these points? So let's just see. So if we reflect D over the x-axis, it would be right here, right? B would be down here, and A would be right there, okay? If we just reflected over the x-axis. So that would be a reflection. And then what happened to the reflection? Doesn't it look like it moved 2 left? Okay, so I'm going to say a reflection. Let me make this pen a little smaller, y'all. Over the x-axis. And what's that rule for that? X comma negative y, right? And then it looks to me like it shifts 2 to the left. Can everybody see that? It shifts 2 to the left. Agreed. So let me pull this back up. Sorry. Let me do it in blue. 1, 2, 1, 2, 1, 2. So it's a translation also. I don't know why I got thick again. Left 2. Okay, so what is that rule? X minus 2y. Okay. So is triangle ABC congruent to triangle XYZ? Yes. And how could we determine that? Look at the sides, y'all. 1, 2, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. And then this rise over 1 is 2 over 4, right? So, but why? Is it congruent? Because it was a reflection, because both reflections and translations are rigid transformations, okay? That's our term we want to use, rigid transformations, okay? Now, on the test, you're going to have to tell me this, okay? Make sure you know it. All right, so over here, we're going to go back to this one now. We're going to do part B. It says, what is the first transformation and its rule? So notice right there is our BD, and BD maps to XY, right? So XZ right there. So what do you think happened? I think it was a rotation too. So if we rotate it down here, that's a what? That would be a 90-degree clockwise or 270-degree rotation, right? So that was our first thing that happened. And what's that rule? That's y comma negative x, right? Okay, then it says, what's the second transformation? So here we go again. Let's look at a point or a couple, maybe. So let's do this. So if we apply that rule to D, D is 2, 1, right? And B is 2, 3, okay? So if we apply our rule to that, what's that going to get us for our D maps to Z, okay? So if we do that, it's 1 comma negative 2, right? So 1 comma negative 2 will be right there. So that's going to be our Z, right? Then if we do the same thing with this point up here, that's going to be 3 comma negative 2, right? So 1, 2, 3, negative 2 right there. Okay, so there's our side dy. And then if we just count 1, 2, 3, 4, 1, 2, 3, 4, that's our other point, right? Up there, okay? So what else needs to happen to this? Can you guys see that it needs to go down by 2? Right. So it's also a translation. I don't know why my pen keeps getting thicker. 2 down. Okay, and that rule is x, x, x doesn't change, so and then it's y minus 2, right? Okay. So then it says, is ABC congruent again? The answer is yes. And it's for the same reason, only this time we can say both what? Rotations and translations are rigid transformations. Got it? Okay. Okay, so this one says, given the following figure, state the triangle congruent statement and list the information needed to prove the triangle is congruent by the following theorems, postulates. Use what is given and mark what is always true. Okay, so it says triangle congruent statement. So let's go ahead and write this. I'm going to start out here at N. So if I start at N there, then don't I have to start at R here? And then I'm going to go to the right angle. That's O there. And the right angle here is Q there. Okay, maybe, yeah, let's try this again. Q. And then what's the last letter that's on both sides? P, right? Now you can go in a different direction, okay? Just know that. That's fine for you to do that, but that's the direction I went, okay? It says, what pair of angles sides would always be marked? That would be our what? Vertical angles, right? So we're going to say angle NPO is congruent with what? Angle RPQ. Okay. Why? Because they're vertical angles. Okay. Now, to prove that these two triangles are congruent by side, 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 we need 3 sides. We have no marks right now on anything, y'all. So I'm going to say an O would need to be congruent with what? RQ. And we got to do another side. So I'm going to do this one and this one. So I'm going to say OP should be congruent with QP, right? And then I'm going to talk about my third side here. Okay, so I'm going to say NP is congruent with what? QP. Okay? Now, I'm going to take those markings off. We're going to leave what's on here. And I'm going to use not the right angle, but I'm going to use our vertical angle, okay, just because I want you guys to get accustomed to writing that. You could use the right angle for this next part because it's asking for side angle side. So actually, you know, I'll just do both so you guys can see it both ways. So if I use the right angle, then I need this side and this side, right? So I'm looking for side angle side. So that would be NO is congruent to RQ, right? Okay. Then we're going to talk about angle O is congruent with angle Q. And then we're going to talk about this other side, right? Again, it's side angle side. So this one would be OP is congruent with QP, right? So that's one way to do side angle side, okay? And that's if I use the right angle. So what if I don't use the right angle, but I use the vertical angle? So if I use the vertical angle, then I'm going to say this side is congruent with this side. So I'm going to do it two different ways here. So NP is congruent to RP. And then what's our angle? Again, we're using our vertical angle this time. So we're going to say angle NPO is congruent with angle what? RPQ, right? Make sure you go the same directions around. So then we need another side, don't we? So we need that side and this side because the angle has to be between the two sides. That's the key to side angle side, okay? So this is going to then be OP is congruent to QP. Okay? So either one of those works, okay? So there's two different ways you could do it. So I'm going to continue to keep that vertical angles marked on here. So now this time, I'm just going to use what's marked initially. Okay, so I'm going to say angle O is congruent with, for angle, side angle, angle Q, right? And I'm just going to use this side right here, y'all, because angle, side angle this time, the two angles are marked. So I'm going to say then OP is congruent with QP. And then again, use our vertical angles. So our third statement is going to be angle NPO is congruent with RPQ. Oops, forgot to put my congruent symbol there. Whoops, I'm just messing up all over the place. So let me try this again. Congruent to angle RPQ. Okay. So our next one is angle side. Okay. So again, there's two different ways we could do this. We could start with angle O and go to P and then go to our side, or we could start with P and go to O and then go to our side. So we're going to do it both ways, just so you guys can see both the answers. So I'm going to start with angle O first. Angle O is congruent with angle Q, right? Then I'm going to say angle NPO. So I'm going here, angle, this is what I'm doing, angle side, okay? That's what I'm about to do. Let me erase that. So again, I would go angle side here. Okay, so NPO is congruent with angle RPQ. There's our two angles. Now what is our side? So then that means our side is going to be NP is congruent with what? RP, right? All right, there's the opposite direction we could go. So let's talk about that. So now, let me clean this up a minute. So this time, if I start with my vertical angle, if I go P to O, then this is going to be my side, right? Again, P to Q, and then this is going to be my side. So this time we're going to go angle NPO is congruent with angle RPQ, right? Then we got our other angle. Angle O is congruent with angle Q, right? And then we're going to do our side at the end. So now we're going to say NO is congruent with what? RQ, right? Got it? All right, so our last one is HL. So the first thing that we have to say for HL is we have two right triangles, right? Can't use HL unless they're two right triangles. And they are both right triangles because they both have a right angle in them, okay? So the first thing we're going to say is we have two right triangles, right? Then we need our hypotenuse, okay? So I'm going to erase all these markings this time. So isn't our hypotenuse opposite the right angle? Yep. So there's our hypotenuse, okay? So we're going to talk about a hypotenuse now. So let me say this, hypotenuse, hypotenuse. Hypotenuses are going to be what? Okay? So up here we're going to talk about NP and RP, right? So NP is congruent to RP, right? Then listen, you could do either leg. I'm just going to choose one, okay? So I'm going to choose the leg NO, which means this leg down here would be what it would also be. Now, you could have chose the other one, so I'm just telling you, I choose this one. You can choose whichever one you want, either the vertical leg or the horizontal one. So I'm going to say NO is congruent to RQ, okay? NO is congruent to RQ, okay? So once again, those are the statements. Wow, I cannot write today, y'all. Those are the statements we need to prove HL. So number 6 says the route for a race goes from point X to point Y. Point X to point Y with 2 checkpoints. The first checkpoint is point C. And the second checkpoint is point D. Okay? It says you are at X 3,750 meters from the first checkpoint C. So 3,750 meters goes right there. The second checkpoint D is located at the midpoint between C and the end of the race. The midpoint C, okay. D, okay. The second checkpoint D is located at the midpoint. So D is at the midpoint between C and the end of the race. That means these two segments right here are congruent, y'all. The total race is 10 kilometers. Well, hopefully you know 10 kilometers is 10,000 meters. Okay? So it says what definition postulate are used to solve this problem? So we have the midpoint, right? Didn't we use the midpoint? That's the definition. And what postulate is the segment addition postulate, right? Okay. So now, what are we going to do to find, it says how far apart are the 2 checkpoints. So C and D is what we're looking for, right? So what we need to do is we need to find the length for CD and the length for DY, right? So what I want to do is take this 10,000 and subtract from it 3,750. Okay? So that's 6,250. Now, because that is both CD and DY, right? Because this was CY, right? So then we're going to divide that by 2 to get CD and DY. So when we do that, we get 3,125, right? So that means this is 3,125 and this is 3,125. Y'all see that? So it says how far apart are the 2 checkpoints? Well, obviously, there's our first checkpoint, there's our second checkpoint, and what was that distance? 3,125 meters. Okay? That was the answer. All right. B says, if B is the midpoint of the line segment AC, if B is the midpoint of AC, so we got AC, and we got B as the midpoint, so that means these 2 segments have to be the same, right? And it says BC is 3x plus 6, and then it says AC, the whole length, y'all, up here is 54, right? Okay. So if those 2 lengths are the same, then there's a couple ways you could approach this problem. Couldn't we put the 3x plus 6 right here and just add those 2 together and set them equal to 54? Indeed, we could do that, yes? So if we do that, 3x plus 3x is 6x plus 12 equals 54. Subtract 12 from 54. 6x is equal to 42. So x is equal to 6, okay? Then it says, what's the value of x? AB and BC. So to find AB, aren't we going to put, so AB is going to be equal to 3 times 6 plus 6. That's 36 plus 6, that's 27. And that's the same length for BC, right? They're going to be the same because of that midpoint word, okay? That's the key. All right, so the next one says a quadrilateral is formed by points L, M, N, O. What are the characteristics of the opposite sides, consecutive sides, and diagonals that justify the shape? Make mathematical statements that show what is congruent, parallel, and perpendicular. Okay, so what I'm going to do first is I'm going to just draw a shape over here, and I'm going to label it so we can talk about it. So this is L, M, N, and O. Okay? So when we start talking about sides, don't we know that opposite sides in a parallelogram are both congruent and parallel? So we're going to say LM is equal to ON, right? And LO is equal to MN. Now, can't we say the same thing about parallel? So LM is parallel to ON, and LO is parallel to MN. Got that? Then we also know that the diagonals, so these are our diagonals right here. This is a diagonal, MO. So MO is going to be, does what to LN? It bisects it, right? Y'all remember that? LN. Okay, so that's our first properties that apply to a parallelogram. Now, those properties apply to everything. So what I'm going to talk about for the rest are the unique properties, okay? So what do we know about a rhombus? You know all four sides are the same, right? So couldn't we say LM is equal to ON is equal to LO is equal to MN? All four sides are congruent, yes? Okay, what else do we know about rhombus? We know that the diagonals are perpendicular, right? So we could say that LN is perpendicular to MO, or the other way around, MO and LN, okay? So now, again, let's talk about unique properties to a rectangle, okay? So a rectangle, what do we know about all the sides? So first of all, we know the opposite sides are congruent and parallel. That's the same, right? So what do you know about the diagonals? So couldn't we say that LN is equal to MO, right? And what do you know about the sides? They're all perpendicular, right? So can't we go all the way around this shape and talk about all these angles right here? So we could say LM is perpendicular with MN is perpendicular with NO is perpendicular with LO or OL. Got it? Those are the characteristics that are unique to a rectangle. Now remember, all the properties we've talked about thus far apply to a square, right? So don't we know that LM is equal to ON is equal to LO is equal to MN because all the sides are congruent, right? We also know that LN is perpendicular. Diagonals are perpendicular, right? So then what else do we know? Don't we know, where's my green? We know also that LN, the diagonals are congruent, right, to MO. And we know that all the sides are perpendicular. So we can say LM is perpendicular to MN, is perpendicular to NO, is perpendicular to OL. So make sure you know these properties, okay? And remember that the properties of a parallelogram apply to all of them, okay? So you can always put them with the rhombus, the rectangle, and the square as well, okay? The next one says parallel lines cut by a transversal, okay? So on this one, we're going to talk through this, and we're going to talk about what we're using to solve these two. So I'm going to go ahead and write where these angles are. So this one's 39 up here, and I'm going to do them in different colors. Angle 12 is 53. Oh, it got thick on me again. I don't know why it keeps doing that. So we're going to go back here. 53. Okay. And then we've got angle 14 is 92. So this is 92 here. So let's talk about what we can do. So I see that angle 1 is a linear pair to angle 2. Can you guys see that? So what I would do to find angle 1 is I would take 180 minus 39. So that was 141. And what I'm going to put up here too is that that angle 2 was a linear pair to it. Okay, that's how I solved it. Okay? So now let's talk about angle 4. What do you notice about angle 4? Oh, actually, let's go ahead and put this in here. 141 right there, okay? So as we work through stuff, I'm going to write it on there. And this is what you should do on the test, okay? So when we get to angle 4, what do you guys notice about angle 4? Me too. I noticed that angle 4 is congruent with what? Angle 2. So we can say that this is 39 degrees. Why? Because angle 2 is a vertical angle to it, right? That's how we solved it, okay? Then what about 5? So angle 5, let's look at angle 5 down there, okay? So what do you notice about angle 5? Anything? So if I look at angle 5, it's a same side interior angle. Let me show y'all what I mean. So angle 5 right here is the same side interior angle with 14, isn't it? So we're going to find another unique measure for that. Let's see if we can find us another color here. Let's see. Let's go orange, okay? So angle 5 is going to be, again, 180 minus 92, right? So 180 minus 92 is 88. Okay, so this was a same side interior to what angle? With angle 5, right? Okay. So angle 6, so we can put the angle 5 up there. This was 88, right? So how would we find angle 6? Angle 6 is a linear pair to angle 5, isn't it? Okay, so let's pick us another color. Trying to keep with some different colors here, okay? So we could say that angle 5 is a linear pair, right, to angle 6. So once again, can't we go 180 minus 88? And that means this is also 92. Well, there's another way we could have done it too. Do y'all notice this right here? These angles are corresponding angles. So we could have also said that they're corresponding angles. So you could have said linear pair, could have used corresponding angles. So either way, justify your answers, okay? And then angle 9 is a linear pair with angle 12, right? So let's see. I need another color. Where's my colors? What color am I going to pick now? Let's pick that really pretty blue, okay? So angle 9 right here. Aren't we going to do 180 minus 53? And that's going to be equal to what? 127, right? 127. So this one right here is 127. And again, why is it 127? Because it was a linear pair with what? With angle 12, right? Okay. Then we've got 10. Where's 10? Oh, 10 is a vertical angle to 12, right? So let's go to our red. So that means 10 is 53, right? Keeps going back to thick for me some reason. I don't know why. So this one's going to be 53 degrees. Why was it 53? Because it was a vertical angle to what angle? Angle 12, right? Okay. 15. Look right here, 15. Oh, 15. Can you guys see that 15 and 5 are what? Alternate interior angles? Y'all see that? So angle 15 is going to be 88. Let's go see if we can get our orange again. Where's my thing right there? Orange. So this is going to be 88 again, right? Why is it 88? Because it's an alternate interior angle to what angle? To angle 5, okay? So we can just write that one. What about 16? 16 is the same as what? 14. So 16 is going to be 92. Y'all see 92 right there? Why is it 92? Because it's a vertical angle to what? Vertical angle to which angle? 14, right? Okay. And then 17. What can we do with 17? Do you guys see what I see? This angle right here and 17 are corresponding angles, aren't they? So this is going to be 127 because it's a corresponding angle to what? to angle 9, right? And then what is 20? Notice 20 is also a corresponding angle to what? 12, right? So this one is going to be 53. 53. Forgot to make that one 127. And again, it's a corresponding angle to 12. So when you guys are doing this on the test, you need to explain how you got these angles, okay? And it could be a variety of ways, so don't think that your way is wrong. So let's talk about this next part. Identify the given angles are congruent or supplementary and explain why. So let's look at these now. We've got 9 and 18. So 9 and 18, I can hardly see my angles, so I'm going to erase this, y'all, just so we can. 9 and 18, 9 and 18. Aren't those are supplementary. They're not the same shape, y'all, okay? That's your key. They're supplementary. Why? Because they're same side interior angles. Same side of the transversal and inside the parallel lines, okay? Okay. So then our next one is going to be 7 and 15. 7 and 15. Oh, these are congruent, right? Why are they congruent? They're the same shape, okay? So they're congruent in their corresponding angles. That means they're on the same side of the transversal and the same side of the parallel lines, okay? Then our next one is going to be angles 3 and 4. Angles 3 and 4 are a linear pair, aren't they? These are supplementary again. Are they the same shape? No. If they're not the same shape, then they got to be supplementary, y'all. And these two are a linear pair. They form a line. Okay? So let's pick orange for our next one. 5 and 15. 5 and 15 are right there. Okay? So aren't those congruent? They are both the same shape, right? And what are they? Alternate. They're on the alternate sides of the transversal. They're inside the parallel lines, so they're interior, alternate interior angles, okay? Then we've got 13 and 7. So let's do our purple here, 13 and 7. So 13 is here, and 7 is up there. Oh, well, they're on alternate sides of the transversal, right? They are the same shape. They're both acute angles, so this is going to be congruent. But they are alternate exterior angles, right? Alternate. They're outside the parallel lines. Alternate exterior. Okay, then our last one. Color. What color should I use here? Oh, we'll use that pretty blue. Okay, that aqua color. All right, so then we've got 11 and 20. 11 is here. Whoa. Pause. So 11 here, 20 there. So they're on the same side of the transversal, right? And outside. Look at those. This is acute. That's obtuse. So they got to be supplementary, right? So these are supplementary. And they're same side exterior. So notice they're on the same side of the transversal, both to the right of the transversal, but they're outside the parallel lines. So these are same side exterior. Okay, so the last one says if the measure of angle 2 is 3x plus 24 and the measure of angle 4 is 9x minus 30, explain how you would calculate the measure of angle 1. So 2 and 4, what is that relationship? Let's go ahead and erase this right here. 2 and 4. They're vertical angles, so that means they're equal, right? So let's go ahead and do it that way, okay? So that means we're going to set them equal to each other, yes? So we're going to say 3x plus 24 is equal to 9x minus 30, right? Subtract 3x from both sides. That's going to give me 6x here. Add 30 to both sides. So that's going to be 54. And 6 goes into 54 9 times, right? So x is equal to 9. Then it says we're trying to find angle measure of 1. Okay, so what is the relationship here of 1 and 2 or 1 and 4? Y'all see it? They form a line, right? So let's find the measure of angle 1. or actually find the measure of angle 2 and then subtract it from 180, okay? So that's what we're going to do. So we're going to find this angle measure first. So I'm going to say 3 times 9 plus 24. Does it matter which one of these I use, by the way? It doesn't, does it? So this is 27 plus 24. What is that? 51? So that's 51. What do we have to do with the 51, though, to find the measure of angle 1? Don't we have to do 180 minus 51? Indeed, we do. So that angle measure is going to be 129 degrees. Okay? All right, so we got one more. So these are exterior angle theorem, right? So we're going to add angle Q to angle P, and it's going to equal this angle out here, right? So we're going to do 35 plus 12x plus 12, and that's going to equal our 16x plus 11, right? So that's 35 plus 12, that's 12x plus 47 equals 16x plus 11. Let's subtract the 12x from both sides. That's going to give us 4x over here. And let's subtract the 11 from both sides. That's going to give us 36 there. So x, 4 goes into 36 9 times, right? So now what are we going to do with this 9? We're going to plug it back up in there, right? So to find QPR, that's this angle right here. QPR, that's this angle. So we're going to do 12 times 9 plus 12. So the measure of QPR is going to be 120. So this one is 120, okay? Then we're going to find QRZ. QRZ. You know what? I'm not going to find that one next. I'm going to find QRP first. So I'm going to find no, I am going to find QRZ. Sorry, QRZ. I'm going to find 16 times 9 plus 11. That's going to be 155. Right? And y'all, what is 35 plus 120? Isn't that 155? Okay, so if this right here is 155, how do we find the last angle, which is this angle inside there, that angle right there? How do we find that? Aren't we going to do 180 minus 155? And what's that going to be equal to? 25, right? So this one is 25 degrees. Okay? For part B, it says find the measure of angle 1, 2, 3, and 4, right? Okay? So on this one, notice we have a linear pair here. So we're going to do, to find the measure of angle 1, we're going to do 180 minus the 92. My pen keeps getting sick on me, y'all. So the measure of angle 1 is going to be equal to 88 degrees, right? Okay, so this one's 88. All right, same thing for angle 2 down here, right? Aren't we doing the same process? We are. So for the measure of angle 2, we're going to do 180 minus 123, and this one's going to be 57. So I'm going to put it right there. Now, what do you know about all the angles inside a triangle? When you add them together, they equal what? 180. You're right. Okay, so we're going to find the measure of angle 3, we're going to add the two angles together and subtract them from 180. So we're going to do 180 minus our 88 plus our 57. So the measure of angle 3 is equal to 35. Okay, so if the measure of angle 3 is 35, how do we find the measure of angle 4? How do we find this one right here, guys? Angle 4. So once again, they form a linear pair, right? So the measure of angle 4 is going to be equal to 180 minus the 35, and that's going to be equal to 145 degrees. Okay? So there you go. And we use the exterior angles theorem for all of those in linear pair. Okay? And triangle sum, actually. We did several things.